Alright, ladies and gentlemen, this is day 2 of the remainder theorem. Trying to figure out factors, and here we go. It says use synthetic division to divide. So we're going to do it with a 3, a 4, and a negative 12. What goes in the box? Well, there's x plus 5. So if x plus 5 was set equal to 0, we know that negative 5 would be a solution to that. So negative 5 needs to go there. So drop the 3. 3 times negative 5 is negative 15. We add, we get negative 11. Negative 11 times negative 5 is negative 55. Or sorry, positive 55. And we add and we get a positive 43. So it just says divide. So we're going to write our answer as a polynomial. So this will be 3x, since we took that x squared and dropped it down a degree. 3x minus 11, then plus 43 over x plus 5. That will be the correct quotient there. So that's 1. Number 3. Here we go. Now, it goes from 4. There's no 3. There's a 2, and there's no 1. So here, we actually need 2 placeholders. One for the x squared, or x to the third, and one for the x. So in the box, that gives me a negative 1. But with the coefficients, I have a 1, a 0 for the third, a negative 3 from right here, a 0 for my x to the first power, and then I have a 12. This is kind of a gnarly problem here. So drop the 1. 1 times negative 1 is negative 1. Add, and I get negative 1. Negative 1 times negative 1 is 1. We add, and we get negative 2. Negative 2 times negative 1 is is positive 2. We add, and we get 2. 2 times negative 1 is negative 2. We add, and we get 10. All right, so our quotient here is x to the third, because we're dropping that fourth down 1 degree. X to the third, then x squared, then x. So x to the third minus x squared minus 2x plus 2, and then plus 10 up top over x plus 1. All right, that takes care of that first section, the ones I'm doing for you anyway. Now, it says, use the remainder theorem to find the remainder for each division. Then, state whether the binomial is a factor of the polynomial. So, a couple questions here. We have to first use division, then we have to say yes or no. Well, then that's a factor, and that is going to, or what's going to tell us that is if the remainder is 0 or not. So that's what we're looking for. So in the box, I have a negative 1. Using synthetic division again, I have 2, I have 4, I have negative 1. Whoop! I don't have my x term, so I have to have a placeholder there with a 9. So we're trying to see if this gives us a 0. If it does, it's yes. If not, it's no. So 2 times negative 1 is negative 2. Add, we get 2. 2 times negative 1 is negative 2. Add, we get negative 3. Negative 3 times negative 1 is a positive 3. We add, we get 3. And then 3 times negative 1 is negative 9. We get 0. Since this is a 0, then we know that this is a factor. So yeah, way to go. 1 down in this section. Next up, let me change the color here. We're trying to see if t minus 4 is. Now this one's a little bit easier. 4 goes in there. There's no placeholder. It goes 3, 2, 1, 0. So here we go, 3, negative 10, 1, negative 5. So I drop the 3. 3 times 4 is 12. We add, we get 2. 2 times 4 is 8. We add, we get 9. 9 times 4, that is 36. We add, we get 31. That is not 0, so the answer is no. T minus 4 is not a factor. It's not a factor of the polynomial. All right, moving on to number 9. This one's pretty wild here. So let's see here. I know 2 goes in there. I know I don't have a 1 or a 0, so if you want to put placeholders there, we can. I don't know if we're going to need to or not. But either way, this is what we do. I'm going to put a 1 there. So 1, 5, negative 14. And if you want to put a 0 here and a 0 here for the 1, 0, go ahead. You don't need to, but you could. And I'm going to show you that you could. Anyway, drop the 1. 1 times 2 is 2. We get 7. When we add, 7 times 2 is 14. We add, we get 0. Now, here I should be able to stop because that's where this one ended. But if you wanted to put more zeros here for placeholders, 0 times 2 is 0. We get another 0, and then another 0, and then another 0. So either way, this 0 right here means that yes, x minus 2 is indeed a factor. Now, I'm going to go ahead and show you this a little bit here because I need to go a little bit more in depth. If we just took this right here and factored it, it's x squared they all have in common. So if we take out an x squared, we're left with x squared plus 5 minus 14. 5x, sorry, minus 14. So that's x squared, and then we could go ahead and factor this. That's factored into x, or two numbers multiply to a negative 14 and add up to a positive 5. Well, that would be a positive 7 and a negative 2. So it would be x minus 2 and x plus 7. Well, look at that. That is a factor. So there we go. So that's another reason why, yes, x minus 2 is a factor. But we use the binomial theorem, which is perfectly fine as well. Now, this is a 3, not an 8. So that's another reason why I'm doing this problem. I'm going to drop the negative 3 from right here in there. And then I have 1, 1, whoop, 0, and then negative 10 because I have to have my placeholder. So there's 1. 1 times negative 3 is negative 3. We add, we get negative 2. Negative 2 times negative 3 is 6. We add, we get 6. And then 6 times negative 3 is negative 18. We add, we get negative 28. So that's not 0. So no, y plus 3 is not a factor. Unfortunately, I didn't really have anything riding on this. It's okay. Now, I showed you the one before, or the other example, where I kind of factored it. I'm going to show you this one as well. Now, we're trying to figure out if one of the factors is x minus 3. I think it might be, but we'll see. This is a yes or no question as well. So I'm going to go ahead and say, since we're trying to see if this is a factor, I'm going to put a 3 right there. Why not? So 1, 6, negative 9, and negative 54. So drop the 1 down. 1 times 3 is 3. We add, we get 9. 3 times 9 is 27. We add, we get 18. 18 times 3 is 54. We add, we get 0. So yes, indeed, x minus 3 is a factor. But what's more important with this, and what's going to help lead into the next section, is if we did do this division, we started with this, we know that x minus 3 is one of its factors. What we're left with is right in here, which is x squared plus 9x plus 18. Now, are there any factors of 18 that add up to 9? Well, yeah, there's 6 and 3. So I have x minus 3 still from what we got, and then x plus 6 and x plus 3. So there are two other factors here, all right, that we could have just factored very easily and found that. Now, I could go back to the beginning here, the very beginning, and if I wanted to, factor this by grouping. So what do these first two terms have in common? They have an x squared in common. You're left with x plus 6. These two, what do they have in common? Well, they have a negative 9 in common. You're left with x plus 6 again. This is factoring by grouping. When those two match up, you can take that out. What are we left with, ladies and gentlemen? We are left with x squared minus 9. So that goes in this parentheses right here. So the x plus 6 is going to remain. All right, but this can keep factoring. X plus 3, x minus 3, and that is this factor. So in answer to this question, is x minus 3 a factor? Yes, it sure is. Just trying to tie in some things that you should have already learned. And last but not least, this is rough. I'm going to ask you just to copy down the work, maybe listen a little bit, enjoy. This is the volume formula for a cylinder. It's pi times the radius squared times h. And this is what we have here. So there's a radius right here, and here's the height. Now, it says the height has to be 4 meters greater than the radius. So if the radius is x, if I call that x, I know the height has to be whatever the radius is plus 4. Okay. So now that I have this, here's the radius, there's the height, I'm going to substitute those values in, just on the right side real quick. So pi times x as the radius squared, and then times x plus 4, which is the new height. Now, determine the radius. So we're trying to figure out the radius is the x of the top of the height of the tank if the tank must have a volume of 15.71 cubic meters. So here's my equation. Now we just have to solve it. Now, this is exactly how I solved it when I was doing this problem beforehand. I'm going to first go ahead and divide both sides by pi just to get the x's by itself to see what we're working with here. So when you do that, you get roughly 5. So I'm just going to call this 5 right now. That's going to make it a little easier. It'll be an estimate, but still, that's where we're at. And I still have x squared multiplied by all this. So I'm going to go ahead and distribute it. So x to the third, here from here, and then x squared times 4 is plus 4x squared. Now in every one of these, what we're going to have to do is get one side set equal to 0. So I'm going to subtract 5 from both sides. So I got this. So I'm a math teacher. I was doing this. I was like, okay, I don't know how to factor that. And it's true. I don't know how to factor it. And I'm perfectly fine telling you that. The problem is, this is on a section with synthetic division. So what we're going to do now is we're going to take this and try and see what works. All right? So I'm going to try, here's my box. There's a placeholder right here in this polynomial for the 1, but I have 1, 4, 0, and negative 5. Those are the coefficients, 1, 4, 0, and negative 5. Now, I'm going to try, and this is exactly what I did, promise. I'm going to try 1, see if 1 works, which is saying, okay, well, is x minus 1 a factor? That's what I'm trying to say, or trying to see. Drop the 1 down. 1 times 1 is 1. We add, we get 5. 5 times 1 is 5. Add, we get 5. 5 times 1 is 5. Add, we get 0. So I was lucky. All right, I knew that this right here factored into x minus 1, I guessed, and then I was left with x squared plus 5x plus 5. Now, this, you'd have to use a quadratic formula to work on it. I guess, no way, it does factor. No, it doesn't factor. Yeah, I was right. You'd have to use a quadratic formula on it, but this works. So the answer here, the radius, is 1 meter. That is the answer to this question. All right, you're going to finish the rest of the evens on your own. Thank you very much.